Alright, so what I was saying there with the standard deviation, y'all simmer down. Standard deviation is just how far away from the mean we're going, how far away we're deviating. Symbol for standard deviation kind of looks like a little 6 with a short flag laying on its belly. Okay. So each of these lines on our chart here is one standard deviation away. So if I'm here at the mean and I move to the left, I would be one negative standard deviation. If I'm here at the mean and I move to the right, I would be one positive standard deviation. Then here would be two positive standard deviations. Here would be three, so on. Okay, so to get here, you would take your mean and add a standard deviation. Add another standard deviation, add another standard deviation, and that standard deviation will actually be a number that we'll compute, so it'll be something. So here we would subtract a standard deviation, subtract another one, subtract another one. Okay, now the stuff that we're going to fill in here, some important stuff on this from just let me write on here, to those dotted lines, that is 68% of the data. Which that means that each of these would be 34, right? Everybody good on that? Filling this stuff in on your drawings? I didn't hear what you said. We're going to keep going and keep filling it in.
Wait, so from the first standard deviation to the left to the first one on the right, it's just 34.
Each of those is 34.
What am I writing?
I don't know. I've written 68 is the width there and 34 is the individual widths. Because, 68, you have that, it's 34. Alright, if we go out another standard deviation, so now if I'm picking up that distance, okay, see what we're doing there? That covers 95% of our data. So from here to here, that's 95% of the data. Now, so we got to figure out how much that means is in each one of those. Okay, well we've already used 68, so what's 95 minus 68? Got a calculator, subtract. 95 minus 68 is 27, and we got half that. 13.5. Good job. Okay, we're going to go one more when you get caught up here. Are you all right?
No. In a second.
Nope.
Or 16.
Yep.
And that's where you got 32.
Did I? Nope. That's where I got 27. Yep. Alright, now I'm going to go one more. So the next standard deviation over would get us right there. Okay, that is going to encompass from where that is over there. That gets almost all the data. You can see there's still a little smidgen of it left on the outsides of that, but that gets to 99.7% of the data. So that's almost all of it. Okay, we already have 95 in there, so what's 99.7 minus 95?
2.7. Wait, no.
Everybody got 4.7? Okay, so now if that's 4.7 that's left over, I want to know what is in here. So I need to half that.
2.35.
2.35 about. I'm just going to go 2.3 for right now. And that's going to get us into the rounding issue that looks like a colon.
It would be a 2.4.
It would be, but, hold on a second, there we go. The 2.35 would round to 2.4, what Kylie's saying is correct, but all of this stuff all along has been rounded. So then that's why when we get to 0.7, it rounds it off a little bit. They can't round that up to 100. And they rounded the whole numbers here, but if they round that to 100, that's saying all the data's in there when it's obviously not all in there. So yes, it does round to 2.4, but it's closer if we kept these, rounded these out to thousandths or 10,000ths, it's closer to 2.3. So that's what most curves we use that you find in books and on the internet and places is 2.3. All right. Pretty good looking stuff. We're going to work a problem or two with it now.
These long problems.
No.
So we're not at the bottom stuff?
We're not yet, but we're going to. But not yet, so don't write all that down yet. What was the other question after David's? Somebody was about to say something. All right. Let's see if it's got. What?
Are we going to have to add more stuff to what we just wrote down?
Probably not. That'll probably be good for you. We're going to learn more, but we won't have to plug it on that. All right. If I had a normal distribution, okay, I'm going to put my mean here. Then I'll have my mean plus 1 standard deviation, my mean plus 2 standard deviations, my mean plus 3 standard deviations, be the other way over here, my mean minus a standard deviation, looks like 60 flatter top there it is. I got tops on those means, there we go. Minus 3 standards. Alright, if I've got this, it says a normal distribution has a mean and a standard deviation. An x value is randomly selected. Find, here's how this looks, find the probability that my mean, started to write out mean, I've got a symbol, that my mean minus 2 standard deviations is less than or equal to x, and x is less than or equal to my mean. Alright, so this is how these problems are going to be given to you. Actually, they're even a little bit uglier than that sometimes, because if you see this out of most textbooks or worksheets or whatever, when they're using mean in statistics, they'll use that funny little u. So remember, if you've got that funny little u, that means mean as well. Alright, let's look at the area that this is concerned with. Standard deviation, taking 2 of those away from the mean. So that would get 2 right here, right? It says x has to be greater than, if I read from the x has to be greater than or equal to that. So I'm going to the right of that. But then it says x has to be less than or equal to the mean. So here's my mean. So less than or equal to that. So on this particular problem, this is the area I'm concerned with. Okay? Well, what does that cover? How much is this section where my mouse is? What's the percentage value there? You just 34. And what's this? What? So altogether there I would have so all that means, what you found with those ugly symbols and fancy stuff there, is that 47.5% of our data, whatever this is data of, it could be anything, would fall in that area. That's what you've discovered. So almost half of the data would fall in that area. Anna? How did we get the number, or how did I know that was the highlighted area? We got from that first picture, there's 34% there, and then 13.5% there. Yeah.
What did you do to get subtract?
No, I added because I'm including both areas. I don't know what, David?
How do you know what's highlighted?
That's what they gave me here. So reading from the X, which is right there, X has to be greater than a mean minus 2 standard deviations. So here's a mean minus 2 standard deviations greater than that. And X has to be less than a mean. So here's the mean, so less than that.
So like after you wrote that problem, it's even
So it's greater than that mean minus 2 standard deviation.
Uh-huh.
And then it's less than
Mean. Now, we're gonna learn a formula for finding standard deviation and all that stuff, so don't think that all we're doing is adding 34 and 13.5 every time. We'll actually learn how to find standard deviations. What I want to get a better grasp of this bell curve, I told you it's called normal distribution, or called a bell curve. It's what's supposed to happen. They don't happen in very often because y'all know stuff that's supposed to happen doesn't. Best laid plans never work. But the easiest example for this is grades. Most common grade, like A, B, C, D, F, that kind of thing, most common grade normally would be a C. Okay, so this would be our C here at the mean. Okay, then you'd have a few more people making B's and D's. Then you get to A's, there's less A's, and F's, there's less F's. So that's how, you could, most people got C's, then you drop down, you got your B's and your D's, and then your A's and your F's. So the lower stuff on that.
I'm just going to rattle those here.
I got it right.
Oh, okay.
You ought to know that by now.
Yeah, I know.
You want to do some statistics with us?
No.
Would you like to or
Oh, okay. Sorry, I'm slow. Thursday, Friday, you're out.
This
Tomorrow
week.
and Friday.
Thursday, Friday, all
Monday.
day. All day.
Monday.
Monday.
And then half a day on Wednesday, or after lunch on Wednesday. So then
Wednesday, PM, and then Thursday.
all day and Saturday, Friday all day.
I gotta do some stuff.
I know, me too.
I gotta teach something to have something that's over. That's what I told them earlier. I said, you just may have a random factoring review, so don't do it.
Just do it.
They're looking at me like,
Okay, but
okay. 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 Thanks.
you're welcome, I think.
As long as we do it
Well,
right.
he's trying to work on for tomorrow too, so I don't, about us leaving it.
But you said all day tomorrow.
Yeah, we're out all day tomorrow, but he is trying to work on letting us leave where all of us can go to the early game.
Why would I be out all day if we weren't doing that?
I don't know. All I know is what they're telling
Okay.
me, so.
Okay.
She said it's easier just getting all day stuff than it is to get,
So I'm out all day tomorrow, but I may go early and I may not.
well, I'm pretty sure we are, but he hasn't confirmed that yet.
Okay. Come back and tell me more stuff to write down as you get it.
I've tried.
Craziness. Alright. I think we're done with that problem. So, what's the matter, Corey?
I'm just blown away. I don't understand. I don't know
Oh,
why.
okay. Let me The only math I did at all was 34 plus 13 and a half. I got that 34 plus 13 and a half from that. This is the same for every normal curve, every bell curve. So these numbers aren't going to change. We're going to use those no matter what. So I might have asked you for how much of the data lies on the right side of the mean. You'd have just added those up. So the dilemma is being able to interpret this gibber. Go to the x, or whatever variable, go to that first. So then reading to the left of it, I'm looking for greater than or equal to the mean minus 2 standard deviations. It's always the mean, 1, 2. So greater than that. Okay. Then I'm also looking for something that's less than or equal to the mean. Less than or equal to the mean. So it had to be in that section. A little bit more. Okay, good. It looks, I got an X in there and I got X's with bars on their heads. So that looks like X overload. That's pretty confusing. But I can read that better than I can when they start throwing this thing in there. I'm like thinking of some foreign language or something. I don't know. What is the, Gracie, you nodded like you knew this. What's the name of this?
I don't know the name, but I've seen it before and worked with it.
I wonder if it's got like a fancy name. I don't know.
Probably. I can look it up, but
No, I don't need to know that, man. Thank you. Okay. This one I got a word problem to read. Says the scores for a state's peace officer standards and training test are normally distributed with a mean of 55 and a standard deviation of 12. The test scores range from 0 to 100. All right, now there's a question that goes along with this, but before we answer the question, we're going to use that to make our curve, to put all the numbers on our curve. Okay, so I'm going to go ahead and get my curve ready. Okay, that line where that vertical line I just drew, what value would go here? 55. Okay, everybody all right?
Is that 100? What is that?
Yes, the scores ranged from 0 to 100. Okay, let's go to the right first. If this is 55, if I go 1 standard deviation past that, what would this be?
67.
Okay, Kylie knew that because she added 1 standard deviation, 55 plus 12. Right? So now when I go another one right here, I just got to add 12 again. 79. Anybody? Okay. Now these go all the way to 100, so I could keep going until I get to 100. I'll just go one more. 79 plus 12, was that 91? Okay, everybody see how we got those numbers? We started with the mean they gave us, and then we just added 12, added 12, added 12. Okay, now when I go to the left, I'm not going to add 12, I'm going to subtract 12. Very good. So this one will be 43. And then 43 minus 12, I think is 31. And then what's this one? 19. Now obviously there's more, but that'll be pretty good for us now.
Wait, can these go in the negatives or not?
Not on this one because they said our smallest number is 0, but they could if we weren't limited by that. All right, so now it says about what percent of the people taking the test have scores between 43 and 67. Well, this one just flat out tells you. You don't have to interpret any gibber like Courtney was talking about. It said between 43 and 67. So about what percentage scored in there? This goes back to that first chart where we put the percentages on there. 68%. Very good. How do I know it's what, sir?
Never mind.
Okay.
Wrote it down.
Oh, okay.
You got 60.
Well, you could add, but I didn't have to. Because I told you that right there. Did that.
Yeah.
Was that. Okay, same data there. Now it says the agency in the state is only going to hire the applicants with test scores of 67 or greater. So about what percentage of the people will have test scores that they can get hired? So we're only going to hire the people that made a 67 or higher. All right. So what?
You add these, you do 13.5 plus 2.3.
Okay, so you got 13.5 plus. No, I'm not going to add the 34 because we got to be greater than that. So this would be the 34. 13.5 would be this first one. And then 2.35, I'll write the whole thing out since I got more room now. 2.35. What else? Do we have anything else we need to add? We didn't put it on that last one, but let's think about what it would be. Let me get my internet picture back up there. So right here where my mouse is, that got me 99.7% of the data. There's 0.3% left, right? So that means if I halved 0.3%, what would be left? 0.15%. Doesn't make that big of a difference, but if it's involving me getting the job or not, I want you to count me. So I'm going to go ahead and add that 0.15%. Oh, I didn't say enough room to write a 5 over there. 1.35 plus 2.35 plus 0.15. And what do we got? That's 13.5. 15.95?
I got 16. I used the 2.3.
Yeah, we did the 2.35.
So 16. So out of everybody that took the test, only 16% of those are even going to qualify for the job. That doesn't mean they're going to get it. That means they're going to qualify. So not very many people are going to get that job. What was it? Peace officer? Not going to be many peace officers.
Yeah, that's what I was going to say.
I don't know. I think it could be.
So like on the first graph that we drew, if we put the 0.15, would in between be 100%?
Yes, that should make the whole 100. Very good, Kyle. We're going to look at a Z-score real quick. Be the last thing we look at. And it's pretty easy because it's got a formula we can just plug into. So let me get us a page started here. This is finding Z-scores. Formula for Z-score is the Z is equal to whatever X value we're talking about minus the mean divided by the standard deviation. Okay, I'm just gonna, I don't like reading to y'all a whole lot, but I don't know a whole lot of stuff about Z-scores, so I'm just gonna read you this little paragraph about what we got here. It says the standard normal distribution is the normal distribution with a mean 0 and a standard deviation of 1. The formula that I've given you can be used to transform X values from a normal distribution into Z-scores having a standard normal distribution. The Z value is called the Z-score, and then it lies above or below the mean. So, I was looking, I'm not even real sure what statisticians use a Z-score for. I'd like to be able to tell you that, though. Mr. Withers says, please review procedure for weather.
Oh, great.
Yeah, there's no tornado warning.
I hadn't looked at it lately, but it was weird.
I looked at
Last
it
night,
this morning.
last night they said we could have
Yeah, I
tornadoes.
looked at it this morning. They said the weather's pretty bad.
Yeah, oh, I hate tornadoes.
Alright, so anyway,
That's fine.
let's do a problem here where we find a Z-score right quick. says a study finds that weights of infants at birth are normally distributed with a mean of 3,270 grams. And a standard deviation of 600 grams. Alrighty. An infant's randomly chosen. What's the probability that the infant weighs 4,170 grams or less? So we're looking for the probability of that. Okay, so what we've got, trying to find the z-score on this. So we would say our z-score is going to equal to, what x value am I looking for? Good, Kelly, what they gave me. So that 4,170 minus, they gave you the mean, 3270, divided by, they gave you the standard deviation. So it just becomes a good old plug and chug problem. Z-score is 1.5. Alright, now when these z-scores, when you're going to see them the most as far as problems to be worked, they're going to have tables. They're going to like have a big table with all the different values on it. So then you would go to the table and find 1.5 on there and make conversions, whatever. I don't use z-scores a whole lot. Let me show you back to some skewed curves. Maybe the last thing we gotta look at. I know I keep telling you that. We had our normal distribution curve, and I told you that one's not very good. I told you when we drew that we wanted that to be symmetrical. So that one's just pretend I drew well. That one's just normal. It's not skewed one way or another. And we could have these things skewed. I could have one that goes and drops down shorter like that. Okay, let me try again on that. Goes up and then drops down shorter. Can you tell what I'm trying to do? Maybe. Okay, that one on what I would have here. If there's my mean, the mean in the middle on that one, the mean on this thing that I'm trying to draw here, it's actually skewed to the left, although it plays in my mind and makes me think right. But here's why it's skewed to the left. The mean on this one, remember back to your middle school statistics, the mean is less than the median. So if your mean is less than the median, it is skewed left. That's the terminology that's used on that. Alright, so if I had one that I went up first and then leveled out like this, I need to scoot this up so we all can see it. This would be skewed right. And the deal with skewed right is the median is less than the mean.
But the median is still in the middle, right?
The median, it means the middle of the data, yes. The middle number of the data, yes. But the mean can be higher or lower than the median. They're not always the same. If they are the same, what would it be? Our pretty one up here. Yes.
Question on our ACT side.
We're late.
Can the mean be less than median?
Did you get it right? Good job.
Sorry, I'm still running.
Okay. I'm not smacking you yet. Alright, so tomorrow you're going to have some kind of assignment. I did already have some made, but I think I was planning on being here tomorrow and teaching another lesson. So that kind of puts me in a quandary. What?
Works out perfect.
No, not really.
For me, because being able to do it.
You still will have to make up the assignment.
I know, but you're having an assignment and I'm not listening to it.
Oh, okay. What you mean?
What are we going to do Friday? Because I won't be here tomorrow or Friday.
Friday. I will not be here Friday
Tomorrow?
or tomorrow. So there'll be assignments. I had some in Chromebook and some on paper. Now I'm not sure where they will be.
Alright.
It'd be good for you if they were on Chromebook, wouldn't it?
I'll check.
Maybe I should try to go that route.
I would appreciate it.
I'll try. I'm not making any promises right now, but I'll attempt that.
Okay, thank
And that would help these Malia people as well.
Median is
Coach
on the
Ray,
right
you know what we
is
should do?
greater than.
We should do a long division.
On that skewed left,
Yeah.
that
Oh
says
my
mean
God,
is
no.
less than
You're
median,
crazy.
which would mean median is greater than median.
Hey, we
Yes.
should do a long division practice.
Median is less than mean.
That's not what the one skewed left says.
No, not that one. I had that one.
Skewed right says median is less than mean. Yes.
Yeah, but long division is the perfect thing.